Look up at the night sky. What do you see? Is it a canvas dotted with countless stars, each one twinkling like a distant gem? Most people would say they see countless stars, a vast and sparkling expanse stretching into infinity. It's a breathtaking sight, one that seems to promise endless mysteries and wonders. It's a sight that has captivated humanity for millennia, inspiring awe and wonder. From ancient civilizations to modern-day stargazers, the night sky has always been a source of fascination and inspiration. But is it an accurate reflection of reality? Are we truly seeing the universe as it is, or is there more than meets the eye? The truth, as astronomers have discovered, is a bit more nuanced. The night sky holds secrets that are not immediately visible to the naked eye. While the night sky might appear to be teeming with stars, the number we can actually see with our naked eyes is surprisingly small. In fact, under ideal conditions, we can only see a few thousand stars. The human eye, while remarkable in many ways, has limitations. Our vision is not equipped to capture the full grandeur of the cosmos. Our vision is constrained by the amount of light our eyes can gather and process. The faintest stars, those incredibly distant or simply not very bright, are lost to our view. The faintest stars, those incredibly distant or simply not very bright, are lost to our view. They require the aid of powerful telescopes to be seen. We are left with a mere glimpse of the true celestial tapestry. The universe is far more vast and filled with wonders than what our eyes can perceive. So, how many stars can we actually see without the aid of telescopes? It's a question that has fascinated humanity for centuries. The answer might surprise you. Despite the vastness of the night sky, our eyes can only capture a fraction of its wonders. Under perfectly dark skies, far from the light pollution of cities, a keen-eyed observer can see approximately 6,974 stars. This number, though impressive, is just a tiny glimpse of the cosmos. That's a significant number, to be sure, but it pales in comparison to the estimated number of stars in the observable universe. Imagine, for every star we see, there are countless others hidden from our view. Astronomers believe there are trillions upon trillions of stars out there, a number so vast it's difficult to comprehend. Each star could potentially host its own system of planets, adding to the complexity and wonder of the universe. The stars we see with our naked eyes represent a tiny fraction of the total stellar population. Telescopes reveal a universe teeming with stars, far beyond what our eyes can perceive. Our view of the universe is further limited by our position within the Milky Way galaxy. We are situated on one of its spiral arms, which restricts our perspective. We reside on a spiral arm surrounded by dust and gas that obscure our view of more distant stars. This cosmic dust acts like a veil, hiding the true expanse of the universe from our sight. Our eyes, while remarkable organs, can also be easily tricked. Optical illusions are a testament to this fact. The way we perceive light and distance can be influenced by a variety of factors, from atmospheric conditions to the structure of our own eyes. In astronomy, these limitations become even more apparent. The vast distances involved mean that light from distant stars reaches us in extremely faint quantities. Our eyes simply aren't sensitive enough to detect this light without assistance. Furthermore, our atmosphere itself can distort and scatter starlight, making it appear to twinkle or shimmer. This phenomenon, while beautiful to behold, further complicates our ability to observe stars accurately. The invention of the telescope in the early 17th century revolutionized astronomy. For the first time, astronomers had a tool that could overcome the limitations of the human eye. The telescope's ability to gather and focus light allowed astronomers to see fainter objects and resolve finer details than ever before. Galileo Galilei, one of the pioneers of telescopic astronomy, made groundbreaking discoveries with his relatively simple telescopes. He observed the moons of Jupiter, the phases of Venus, and the craters on the moon, providing evidence to support the heliocentric model of the solar system. The telescope, in essence, extended human vision far beyond its natural limits, opening up a new window into the cosmos. Section 5. Seeing the light. How do telescopes enhance our vision of the stars? The answer lies in their ability to collect and focus light. A telescope's primary mirror or lens acts like a giant eye, gathering far more light than our small pupils ever could. The larger the diameter of the telescope's mirror or lens, the more light it can collect and the fainter the objects it can detect. This is why astronomical observatories around the world strive to build telescopes with increasingly larger mirrors. Once the light is collected, it is focused to a point, creating a brighter and more detailed image than our eyes could perceive on their own. Section 6. Beyond human sight. Telescopes, however, are more than just giant eyes. They are often equipped with additional instruments that further enhance our ability to study the cosmos. Cameras, for example, can capture images of celestial objects with incredible detail, allowing astronomers to study their structure and evolution. Spectrographs, on the other hand, can analyze the light from stars, breaking it down into its component wavelengths. This analysis reveals the chemical composition of stars, their temperature, and even their motion through space. These instruments, combined with the light-gathering power of telescopes, provide astronomers with a wealth of information about the universe, far beyond what our eyes could ever perceive. Section 7. Unlocking the spectrum. But the universe speaks to us in more than just visible light. Celestial objects emit a wide range of electromagnetic radiation, from radio waves to gamma rays. Each type of radiation carries valuable information about the objects that emit it. Our eyes, however, are only sensitive to a tiny portion of this electromagnetic spectrum, the visible light we see as colors. To unlock the full secrets of the universe, astronomers need to observe it across the entire electromagnetic spectrum. This is where specialized telescopes come in. Section 8. Radio waves from space. Radio telescopes, for instance, detect radio waves emitted by objects in space. These waves can penetrate the dust and gas that obscure our view in visible light, revealing hidden regions of the universe. Radio astronomy has led to the discovery of pulsars, rapidly rotating neutron stars that emit beams of radio waves, and quasars, extremely luminous and distant objects powered by supermassive black holes. By studying radio waves, astronomers can probe the early universe, map the distribution of galaxies, and study the formation of stars and planets. Section 9. High-energy astronomy. At the other end of the spectrum, X-ray and gamma-ray telescopes detect the most energetic radiation in the universe. These high-energy photons are emitted by extremely hot and violent objects such as black holes, neutron stars, and supernova remnants. X-ray and gamma-ray astronomy allows astronomers to study the most extreme environments in the universe, where matter is subjected to intense gravitational fields and temperatures. By observing these high-energy emissions, astronomers can learn about the life cycle of stars, the physics of black holes, and the nature of dark matter. Section 10. Telescopes, eyes on the universe. Telescopes in all their forms are our eyes on the universe. They allow us to see beyond the limitations of our own vision, to explore the cosmos across vast distances and time. From the first crude telescopes used by Galileo to the sophisticated instruments of today, telescopes have revolutionized our understanding of the universe. Each new generation of telescopes brings with it new discoveries, pushing the boundaries of human knowledge and challenging our place in the cosmos. Telescopes are not merely tools for observation. They are instruments of exploration, discovery, and wonder. Section 11. The future of discovery. As technology continues to advance, so too will our ability to explore the universe. The tools and instruments we use to gaze into the cosmos are becoming more sophisticated, allowing us to see further and with greater clarity than ever before. New telescopes, both on Earth and in space, are being designed and built, promising to reveal even more about the cosmos. These advancements are not just incremental, they represent significant leaps in our observational capabilities. The James Webb Space Telescope, for example, launched in 2021, is the most powerful space telescope ever built. It is equipped with cutting-edge technology that allows it to capture images and data with unprecedented detail and precision. It will allow astronomers to peer back in time to the early universe, study the formation of the first stars and galaxies, and search for signs of life on other planets. This telescope will help answer some of the most profound questions about our origins and the nature of the universe. The future of astronomy is bright, and telescopes will continue to be our guides on this incredible journey of discovery. As we develop more advanced technologies, our ability to explore and understand the universe will only grow. With each new observation, we gain a deeper understanding of our place in the universe and the wonders that lie beyond our world. The discoveries we make today will pave the way for the explorations of tomorrow, inspiring future generations to look up and wonder.